Hi guys, let's we discuss session 4 for SHM. SHM Concept and Formula Revision. SHM Concept and Formula Revision. Formula Revision. Session 4. Session 4. In this session we are talking about if a spring block, if there are many springs connected with one or more pulleys and a block oscillating in this type of system and we have to calculate the time period. So we are using a trick is to calculate time period when we are not sure whether springs are in parallel or series combination. Not sure that springs are in parallel or series. Then in that case we have to use 1 over k equivalent equals to 1 over k1 dash, 1 over k2 dash, 1 over k3 dash, and so on. And second step is what is k1 dash? K1 dash is tension in mass, tension in a spring square into k1. What is k2 dash? K2 dash is k2 tension in mass, tension in a spring whole square, and so on. And so time period will be 2 pi under root m into 1 over k equivalent. And what is 1 over k equivalent here? 1 over k equivalent is m 1 over k1 dash plus 1 over k2 dash and so on. Let's we apply this trick in some examples. Suppose in example 1 there is a pulley clamp and there is a spring having constant k and there is a mass. We have to find time period of this system. As if tension in mass is T, as a springs and total lengths are massless, so tension here also T. So tension will be 2 pi under root m multiply 1 by k equivalent. So what is 1 by k equivalent? So only one spring. So suppose this is k1. So this is 2 pi under root m by k1. What is k1? K1 is k, tension in mass, tension in a spring whole square. So k1 dash is k1 and k1 is k. Tension in mass is t, tension in a spring is t ka whole square. T gets cancelled, so k. So here k1 dash is k1 dash is k1 dash is k. So time period is 2 pi under root m multiply 1 by k. This is the required answer. Suppose in the next example, there is a block of mass m in the form of like this and body goes along like this. This is a system. Constant is k. So tension on mass is what? If this part have tension T, this part also will have a tension T. So what is tension in mass? Tension in mass is T and T. Tension in mass is 2T. Tension in mass is 2T. And what is tension in a spring? Tension in a spring T. So if this is K1 dash, K1 dash is what? K1 dash is K. Tension in mass, tension in a spring ka whole square. So tension in mass is 2T over T square, that is 4K. So time period is 2 pi under root m multiply 1 by K1 dash. So 2 pi under root m multiply 1 over 4K. So this is our required answer. In the next example, suppose there is a spring. Suppose there is a spring here having constant K1 and here there are another spring having constant K2 and there is a block connected with the K2 of mass m. So what will be the time period of this block? Suppose tension in mass is T, so this spring also will have a tension C, and to balance it, this spring have tension 2T. So what is K1 dash here? K1 dash is K1, tension in mass is T, tension in a spring 1 is 2T ka whole square, that is K1 over 4. So what is K2 dash? K2 dash is K2, tension in mass is T, tension in a spring is T ka whole square, that is K2. So what is time period? Time period is 2 pi under root m into 1 over K1 dash plus 1 over K2 dash. That equals to 2 pi under root m. What is 1 by K1 dash? 1 by K1 dash will be 4 over K1. And from here, what is 1 over K2 dash? 1 over K2 dash is simply K2. So this is our required answer. In the next question, suppose there is a block of mass m and there are many springs connected to the block like this. There are many springs. Springs constants are K. Spring constants are K. So what will be the time period of the block here? Here there are many springs. Suppose this spring is 1, this spring is 2, this spring is 3, this spring is 4. So we have to find here mass. Tension in mass is what? Tension in mass. Taking a BD. If here tension is T, here also tension T, here also tension T, here tension 2T, here tension T. Because same string is going over here. So tension in all the part remains same. The overall tension acting on the mass is 40. So what is K1 dash? What is K1 dash? K1 dash is K. Tension in mass. Tension in mass is 40. Tension in a spring is T. Ka whole square. Means 16K. What is K2 dash? K2 dash is tension in mass. K2 dash is K. Tension in mass. Tension in a spring whole square. That is 16K also. What is K3 dash? K3 dash is K3 tension in mass, tension in a spring whole square. 16K. What is K4 dash? K tension in mass, tension in a spring whole square. 16K. So what will be the time period here? 2 pi under root m into 1 over K1 dash, 1 over K2 dash, 1 over K3 dash plus 1 over K4 dash. So T equals to 2 pi under root m 1 over K1 dash is 16K plus 1 over 16K plus 1 over 16K plus 1 over 16K. That comes out to be time period equals to 2 pi under root m into 1 by 16K multiply 4. So 4 4 is 16. Time period is 2 pi under root m over 4K. Method 2 we can apply in this question because a single spring going like this, here springs are present, here springs are present, here springs are present, here also springs are present. So these all springs are connected with a single wire end to end having constants of K. So these are in series combinations. These are in series combination. These are in series combination. So what is K equivalent? K equivalent is K upon 4. What is K equivalent? K equivalent is K upon 4. In the next question, suppose there is a spring. There is a spring like this. And there is a block of mass M. So what will be the time period of this block system? So suppose this one is K1 and this one is K2. Here tension in mass is T and T balanced by T by 2, T by 2. So what is K1 dash? K1 dash is K tension in mass, tension in a spring ka whole square means K. What is K2 dash? K2 dash is K tension in mass is what? Tension in a spring is what? A whole square, that is 4K. So time period will be, time period is 2 pi under root m 1 over K1 dash plus 1 over K2 dash. That equals to 2 pi under root 1 over K1 dash is K and 1 over K2 is 4K. So solving we get 2 pi under root m 4K LCM 4 plus 1 is 5. So this is our answer, under root 5m over 4K. So this is the required time period. This is the required time period. Suppose there is a system like this. Suppose there is a system like this. So what will be the time period of this system? Again here constants are k. So suppose this one is first spring and this one is second spring. So what is K1 dash? Here tension is T, as there is a single string system, so tension in all the part are T. So K1 dash is K, tension in mass, tension in spring ka whole square. What is K2 dash? K2 dash is also tension in mass, tension in spring ki whole square. So time period will be 2 pi under root m1 over k plus 1 over k. That is t equals to 2 pi under root m over 2m over k. 2m over k. So this is required answer.